start 6.9a, that's the last lesson of chapter 6. We have something called the hyperbolic trig functions. The way we note that is it looks like sine, but there's an H which stands for hyperbolic. Here's the definition. So the hyperbolic sign is really this function made up of some exponentials. This would be read the hyperbolic cosine. It's another function made up of exponentials. And then the hyperbolic tangent is defined in a similar fashion as the regular tangent is. So the H is for hyperbolic. So what's this all mean? Well, these functions are very significant if you go into engineering, and they'd be used a lot. For ours, it's just some new types of functions, and then every new type of function has a derivative. Let's look at this, which is our notes about the derivatives. The derivative over the hyperbolic sine is a hyperbolic cosine. Works like the regular trig functions. The derivative of the hyperbolic cosine is a hyperbolic sine. Not quite like the regular trig functions, but similar. And then the derivative of the hyperbolic tan is the hyperbolic secant squared of x. So yes, there are hyperbolic secant functions, hyperbolic cotan functions, and hyperbolic cosecant functions. We're just not going to learn their derivative rules. What we're going to do here is 3 derivative problems. Students, these are chain rule problems because I've laid out the basic derivative rules here. Our first function is, let's find the hyperbolic sine of 5x. Just like regular trig functions, this is not product rule because to do the hyperbolic sine, you have to do it of something. This is one complete function. I'm going to consult my rule up here. The derivative of hyperbolic sine is hyperbolic cosine. As with every chain rule problem, we're going to keep the quantity of 5x. But since it's chain rule, we need to do the derivative of the quantity. The derivative of 5x is 5. And there's your answer. Now let's look at 7 hyperbolic cosine of 9x squared. We're going to be referencing this rule here. And this 7 is just going to be living out in front as it's constant. 7, the derivative of hyperbolic cosine is hyperbolic sine of, I'll keep the quantity like I do, and then I'll conclude by multiplying by the derivative of my quantity, which is 18x. One more to go here. That says we need to find the derivative of the hyperbolic tan of the natural log. There's my derivative rule. So the derivative is going to go secant squared, gotta squeeze that h in for hyperbolic, of natural log of x, which you notice is like the trig derivative. And then I'll conclude with the chain rule. Recall what the derivative of natural log of x is. It's 1 over x. Students, coming up in the next lesson, we will be doing the antiderivatives for these problems.